Machine learning models allow our applications to perform highly accurate inferences. A model can be used to classify a picture of a cat or to predict what movie I might want to watch. But before a machine learning model can be used to make these inferences, the model must first be trained and deployed. In the training process, a machine learning model consumes a dataset and learns from it. The training process can consume significant resources. After that training process is over, you have a trained model that you need to get into production. And this is known as the deployment step. Deployment can be a hard problem. You're taking a program from a training environment to a production environment, and a lot can change between these two environments. In training, you are running your model, you're training your model in an environment where you have access to lots of resources, and it's a different machine than what it's running on in production. And this can lead to compatibility issues. If your model is trained in one environment and you deploy it to another, who's to say that it's going to run in that new environment? If your model serves a high volume of requests once it's in production, then you might need to add scalability to that model. And in production, you also need all kinds of things like caching and monitoring and logging. Large companies like Netflix and Uber and Facebook have built their own internal systems to control the pipeline of getting a model from training into production. Companies who are newer to machine learning can struggle with this deployment process. And so these companies usually don't have the resources to build their own machine learning platform like a Netflix or an Uber. Diego Oppenheimer is the CEO of Algorithmia, which is a company that has built a system for automating machine learning deployments. This is the second cool product that Algorithmia has built, the first being the Algorithms Marketplace that we covered in an episode a few years ago. They still run that product, and it's quite a fascinating product. I think if I wasn't running Software Engineering Daily today, I would certainly look at Algorithmia as a place to potentially build on top of, because it's this marketplace of different algorithms that you can access via API. But this show is not about that algorithms marketplace. It's about the deployment system that they've built, which leverages their previous system. So in today's show, Diego describes the challenges of deploying machine learning models into production and how that deployment system was a natural complement to the algorithms marketplace. Full disclosure, Algorithmia is a sponsor of Software Engineering Daily. Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do It International. Do It International helps startups optimize the costs of their workloads across Google Cloud and AWS, so that the startups can spend more time building their new software and less time reducing their cost. Do It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization. And if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/SE Daily and see how much money you can save on your cloud deployment. Diego Oppenheimer, welcome back to Software Engineering Daily.
Thank you very much for having me.
You are the CEO of Algorithmia, and the last time we spoke, we talked about your algorithm marketplace. So some people use Algorithmia for deploying their machine learning models, and other people call those machine learning models. How has that marketplace evolved since we last spoke?
Absolutely. So interesting enough, when you're building a marketplace, a lot of times people are going to talk about this chicken and egg problem. And, how do you get supply? If you don't have demand, how do you get demand if you don't have supply? And one of the things that we had looked at is we said, well, we think there's a lot of supply out there. And this is something that we kind of covered last time. There's a lot of people who've created algorithms, functions, models that they want to do. And so we spent a lot of time thinking about how do we get the path to acquisition as easy and as smoothly as possible from a software development perspective. So how does a developer, essentially, could we get it down to git push, right? That's the meta way of approaching this. And essentially we built a lot of tooling, a lot of UX, a lot of, functionality. So to make it, as close to all you really need to do is from your terminal do a git push, and then you can essentially publish out your algorithms, functions, and models. Surprisingly, in the world of data science and machine learning, this is a tool that didn't exist and really attracted data scientists and machine learning engineers because of the difficulty that they were having grabbing their TensorFlow models or Keras models or scikit-learn models and actually being able to publish them and host them and run them in production. So the tooling that we initially built for easy acquisition or for making the life of developers easy ended up being kind of like the actual gateway for people really looking at us and saying, hey, this is exactly how I want to do deployment and hosting because it makes the whole process so easy.
So you were seeing people use the Algorithmia deployment system that you made for a marketplace. You were seeing people use it for just their own models, so deploying their own models and then consuming their own models that they deployed.
Yeah, exactly. So this interesting concept is we saw this category of what we would call private algorithms start really rising, and especially when it came to how much they were being used. So we would look at the Algorithmia marketplace and we say, okay, so there's these algorithms that are being published and other people are consuming them, or models that are being consumed. But then there's this really large rising category of models that were being put into the platform, never published publicly to kind of essentially the public index, but had a massive amount of consumption. So this idea of they were essentially using our tool as a private hosting service for their models, and the volume was actually really impressive. So we started exploring kind of what that experience looked like and who those developers were and what they were doing. And what we found was that there was this non-trivial amount of data scientists and machine learning engineers who were really struggling going from, hey, this works on my laptop, to I can run this as a large scalable service that is needed for my applications. And look, happens to be that if I just put these things in private mode in Algorithmia, this is exactly what I needed. So it was one of these, we had a general idea that this was going to happen, but actually at the speed and the quantity and volume at which it picked up was really kind of the surprise.
The developers who were doing this, who were deploying their own models and then consuming their own models, what were the problems they were encountering with the other ways that they were trying to deploy their models into production?
Sure. There's a couple of different things that were happening. One, very different skill set, right? So if you think about the skill set that a data scientist has or the machine learning engineer has, highly trained in statistics, understanding kind of what the new frameworks were, how to do data processing, but scale, APIs, monitoring, uptime, these are just things that are not really part of the lingo or things that they've generally encountered. But given the teams and how they're being built, at these companies, they were essentially being put in charge of doing not only the data collection, structuring, modeling, ETL, the whole thing, but then on top of that, now they're expected to run kind of services. And this is just not something that they have experience for. So they would be bringing in platform developers or other engineers to actually build that out for them, which ends up with bespoke solutions. So you kind of get these like one-off serving platforms for specific models. And then you get the problem of, when you're essentially throwing code over a wall for somebody else to like productionize, as you well know, now you suddenly get like bifurcation of code, like updates that don't make sense. Like it's just the software development process actually breaks down quite a bit. And so what this does is by automating kind of the production side of things, it allows the data scientists and machine learning engineers to continue having control of the full life cycle without having to worry about how the production part really like have to build it themselves. And on top of that, we still give the kind of monitoring tools and the scale and the security and things that the platform team would want from a backend perspective.
So as the CEO of the company, this puts you in an interesting position because you were seeing that people were using the platform for one case that it was not originally designed for, but I'm sure there were plenty of other people who were continuing to use it for the algorithm marketplace purpose. Was there any tension between thinking about those two use cases and trying to build a solution for both of those products at the same time?
The interesting part is that it's actually the exact same mechanism and it's the exact same platform, right? So this was just more a difference in behavior that we expected. We still need to acquire these models. We still need to have more of them. One of the things that we notice is that actually people will come to host their private models, but then also explore the marketplace to kind of attach it as if it were, to build out AI pipelines. So really what changed to a certain degree was how the acquisition was going to happen. So if you think about how people come to us, we initially were like, okay, well, they might come to us for a specific sentiment analysis algorithm or for a crowd augmentation algorithm or for some sort of image processing algorithm. But the truth was that we have a large amount of people that come to us to host their own models and then go out and explore the marketplace as like a kind of add-on, which if you think about it is really in line with how platforms work, right? So if you think about how, the most popular platforms out there that we work with, they start out with a platform and then they add kind of like add-on marketplaces or add-on perspectives. And this was not something by design, but natural behavior that ended up with our developer population, which is they came because we solved their immediate problem, which is how do I host this? And then they found things to complement their workflows right there.
So I want to talk about the engineering of this machine learning deployment system. So as you said, it's whether people are deploying their models to be consumed by random people or to be consumed by they themselves, it's very similar technology. And if you think about a giant company like Amazon, when they started building their internal services or they started doing their service-oriented architecture, the legendary memo to everybody in the company about how their services are going to be deployed, it did sound very much like this. Like you deploy your services, even if you as a team within a giant company like Amazon are going to be the only consumers of that platform, you deploy it in a way such that it could be externalized, such that other people in the company could easily consume it. And it sounds like that principle extends to you building this marketplace of machine learning model deployment. So I want to talk about that. So if we're talking about machine learning model deployment, instead of just these normal RESTful services, people think about just deploying their own microservices. It seems like there are some stark differences between deploying those two types of services. And I think this is why people like Uber or Facebook, they create their own AI model pipeline, which I think consists of all this tooling around the deployment process, maybe even the training process. So these AI pipelines at places like Uber or Facebook, what does that consist of?
Yeah, absolutely. So I think it's worth mentioning that the world of, although there's a general desire of always having an all-in platform, the fact is that training and productionizing or deploying or operationalizing, whatever the word you want to use there, is very, very different. core differences. For example, like the training process, it's stateful, right? So like you need to keep state during the training process. It's usually single user. It's usually very long running from like a per job perspective. It's very long running, uses tons of GPUs and CPUs and gets distributed amongst many machines, uses a ton of data, right? So data locality and the amount of data used in that process is very big. On the flip side of that, if you start thinking about what the operationalization is, or what some people call inference of a model, which is the actual classification or prediction side of things, it's usually stateless versus stateful. It's short but very intense bursts of compute. And it's by definition usually a multi-user problem, right? So if you think about, I have a fraud model that's running, every credit card transaction that I run, right? Like there's millions upon millions of endpoints potentially hitting that model at the same time, or replicas of that model to process that transaction and give back a result, which lasts only very, very few seconds. So if you boil down to the problem to its bare like kind of characteristics, the training and the operationalization side of things are very, very different. And so designing a system that encapsulates both is going to be difficult, hard, or you're going to have to give up on one side or the other, right? And you can see that in the industry that we've seen is like there's been a specialization towards one side or the other. So when talking about AI pipelines or things like you mentioned, like the projects like Michelangelo or Twitter's DeepBird or TRX at Google or Facebook Learner Flow at Facebook, the project itself tends to be the encapsulation of both training systems and production systems, but those systems are actually quite separate. And the main driver to get those things out is this idea that like, hey, we productionize one model, we productionize the second model, we productionize the third one, like, oh, we might be doing this a lot. We might be adding models to a lot of the different pieces of our organization. We probably want to reuse these in a lot of cases. And how do we make sure that we only have to build this once, but then also follow a certain pattern so that we can scale them, monitor them, et cetera? And so these companies have noticed that, AI is here to stay to a certain degree, and machine learning is probably important for them, and that they're going to be integrating into multiple different parts of their organization. I think Facebook stats said that 25% of their engineers interact with FB Learner Flow. I believe that's an accurate statistic. And so if you start thinking about the size of the amount of people who are going to be interacting with the serving side of things, and the fact that like their machine learning and AI teams are actually fairly small compared to the rest of the developer organization, now you suddenly start seeing why it's really important to start a certain level of standardization, but also centralization around these services and the mechanisms that you do it. So that's kind of really the driving force. And so this is very much in line with what we see in terms of behavior, where not only are people using us as their hosting service, but they're also adding many more models under their accounts, and different parts of their engineering organizations are using that. And that's also led to our essentially full-blown enterprise product, where we've actually grabbed everything that we've built for the marketplace, including all our admin tools, metrics, everything that we built from the back end to run algorithmia.com, and we've productized it, and we now deliver it to the largest organizations in the world so that they can actually run internally their version of a serving platform in the similar way that Twitter built their own, and Google built their own, and Facebook built their own. A lot of companies do not want to build their own. They want to buy this product, and that's what we've actually been giving them.
The Casper mattress was designed by an in-house team of engineers that spent thousands of hours developing the mattress. And as a software engineer, you know what kind of development and dedication it takes to build a great product. The result is an exceptional product. When you put in the amount of work and effort that went into the Casper mattress, you get something that you'd use and recommend to your friends. And you deserve an exceptional night's rest yourself so that you can continue building great software. Casper combines supportive memory foams for a sleep surface that's got just the right sink and just the right bounce. Plus, Its breathable design sleeps cool to help you regulate your temperature through the night. Stay cool, people. Stay cool. And buying a Casper mattress is completely risk-free. Casper offers free delivery and free returns with a 100-night home trial. If you don't love it, they'll pick it up and give you a full refund. Like many of the software services that we have covered on Software Engineering Daily, they are great with refunds. Casper understands the importance of truly sleeping on a mattress before you commit, especially considering that you're going to spend a third of your life on that mattress. Amazon and Google reviews consistently rank Casper as a favorite mattress, so try it out. Get a good night's rest and upvote it yourself today. As a special offer to Software Engineering Daily listeners, get $50 towards select mattress purchases by visiting casper.com/SEDaily and using the code SEDaily at checkout. You'll get these select mattress purchases if you go to casper.com/SEDaily and enter the code SEDaily at checkout. Thank you, Casper. So the flavors of software engineering that exist within one of these AI platforms that Uber has built or that Facebook has built or that Google has built, how similar are they across the different companies? Because I think in our last conversation, we talked a lot about the variety of container orchestration solutions that there were 2 or 3 years ago. I mean, there still are a variety, but there's been convergence. It's one of these things where people were trying different things, but there's an advantage for the ecosystem as a whole to eventually converge on a single solution because, we find that many of these problems in software engineering, it's the same problem at every company, in every product. And so container orchestration is one of those examples where, Mesos works in some contexts, Kubernetes works in some contexts, but in general, Kubernetes is it does the job. And, in our last conversation, I don't know if you remember, but we talked about sort of the lack of a winner-take-all nature in software engineering in general, but AI training and deployment, if I talk to Facebook about AI model training and deployment, and I go and talk to Uber about AI model training and deployment, are they going to tell me that they do the same things or very similar things, or is the use case different? Is the fact that I'm developing an AI platform for Uber and is being deployed to its real-time gig economy application, is that starkly different than the problems that Facebook is tackling?
So I think we can separate it in a couple of different things. One, which is on tooling and idea behind tooling or what they've used. And then the second one is around use cases, right? So not hard to imagine that Facebook probably spends really, really a lot of time on NLP problems, so natural language processing. Understanding what the updates are, understanding what news articles say, understanding what's being, how to do relevancy for their ads, understanding what conversations are about, what people are talking about, what the relationships between people talk about. So you can see them spending a lot of time. And if you go look at their research, which they make pretty public, they spend an immense amount of time on natural language processing. Same thing for images. They spend a ton of time on images and being able to understand the meaning of images. And so one of the things that, if you want to group this into a category, which is a really broad category, so it's a little bit unfair, but Facebook spends a lot of time doing AI for unstructured data, right? If you think about, free-form text, free-form images, free-form voice to a certain degree now, free-form, so they spend a really lot of time. So you can see that they will probably, everything that they do, my intuition would be that they probably need to build the best tooling for dealing with unstructured data. On the flip side of that, Uber doesn't deal with that much unstructured data. So we can go find use cases, I'm sure, of them trying to figure out things on images or maybe for their self-driving car stuff. But the truth is that probably most of the data that Uber deals with is structured, right? In the sense that they have GPS coordinates, movements, what the accounts are saying, where they started, where they ended. So a lot of the training and a lot of the building of models is probably around route optimization. It's probably around pairing and auctions and smart agent resolution. I think they just mentioned an article recently that they're trying to detect if somebody's drunk before they get on the car or not. And they do that by understanding, like, you call the Uber, and they're kind of picking up on signals around like what your GPS movement is, like how you're moving, et cetera, which sounds really creepy, but like they're trying to figure out, this is research, not like something that they're doing. But they can kind of make an assumption of like, well, if you stumbled across like 17 streets before you got to your Uber, then maybe you're going to be in a certain state of mind that is not ideal for the driver. And so the problem sets are different. And so because the problem sets are different, the preferred tooling might be different. So that's one angle, right? So like where it's like, and I actually know that, like Facebook does a lot of PyTorch, right? And PyTorch has like really been, and they talk a lot about that. And the Cafe is the other one that they use a lot. Cafe too, so because it works on mobile. So they use certain frameworks and tools because they're super comfortable with them. They've also kind of like done their bet on putting back work into those open source projects. And so to make it even better for them. I know that Uber, for example, is pretty heavily invested in TensorFlow. And so what ends up happening is that these companies, they come, especially because they're fairly research driven, right? Like you have some like really famous people working on the labs there on, and all of these in terms of AI and machine learning. They make a bet around a tool and then they go build out the tooling that they need for that tool and framework. That's a little bit different from how it's going to happen wider, right? So when you start thinking about, I'm a Fortune 100 company, and so I'll pick a random example of a company that like I know has a lot of developers. So like JP Chase has 28,000 developers, right? So to just give you an idea, right? So that's like, if you don't count the drivers, I'm pretty sure that's like significantly more than the total amount of people that work for Uber. And that's just developers, right? And so if you start thinking about, well, if the world of machine learning is really going to penetrate every single side of development, it's going to appear in all sorts of lines of businesses, then it's not hard to start imagining that a company like JP Chase needs to start thinking, how are 28,000 developers going to interact with data science and machine learning? And at that point, the use cases are way more varied, right? So like you can imagine fraud on credit card all the way to like, HR problems to, accounting problems, like the whole gamut of things, where you're not going to make a bet on a tool, you're now going to have to make it a lot more generic, right? So kind of like this idea behind kind of how like app servers were pretty generic. You could like launch any sort of app from them. And so that movement, I think, as we see larger companies with larger developer populations, which have much more heterogeneous use cases and needs, then more generic platforms are going to be needed. And now you start building as a general platform, it becomes a lot harder to build that type of stuff internally.
Yeah, now when you're talking about the differences between a company like Uber and a company like Facebook, first of all, these companies have the resources to build their own specific thing, and they've developed a core competency in machine learning, so they're comfortable enough rolling their own. That's one side of this conversation. But the other side of it is like what you said about the core difference being like the structured versus unstructured data. That seems like more of a question of like, how is the data being presented to the training platform or the training process? And it has less to do with the deployment, because once you have the model trained, and you're ready to deploy it and like present it to anybody that's going to consume it, you can separate that as a disjoint problem. So are you thinking about like, is the solution that you build, is it mostly for the deployment process, or are you also involved in the training process?
You can train on our platform, though it's not what we really specialize on. We are deployment and then the runtime. And to your point, I'll clarify that you're absolutely right, where the unstructured versus structured data is really important at the training time, but actually at the prediction or classification time is just as important, because the input into the classification problem is going to be either a unstructured image or an unstructured video, or it's going to be an actual structured data source, like maybe a Redshift storage. So you will see the separation between structured and unstructured data on both sides, because you're going to have to do that. So I'll give you you're an e-commerce website and you're writing a recommendation model on your front page, right? And you're tuning this recommendation model in one way or another. the access to those indexes, to the kind of like doing the nearest neighbor type stuff, that is going to be from a structured data source in almost all cases. Versus if you're doing
a product catalog.
Correct, exactly. Product catalog or some like actually generated tables of affinity that might have been built by your data science team internally saying, hey, people who want this product also want this, or these products are related and stuff like that. Versus, I upload an image to Facebook and it immediately tags my friends and says, hey, should I tag, Jeff in this? Should I tag Diego in this? There's a different at the classification point, which is also on the structured and unstructured data point.
So just to clarify for people who don't know, so the difference between structured and unstructured data, I think, could be defined as the degree of schema. I mean, well, it's hard. I mean, first of all, it's a blurry definition. So like structured data would be something like, we could say structured data is something like a product catalog where the fields are well defined. You've got the title of a product, you've got maybe the SKU number, maybe you've got an image associated with the product. But if you're talking about an image itself, like a photo is a very high dimensional piece of data. You can derive a lot of different things from a photo, or, something like an audio file. It's a very rich piece of data. So from your point of view, why is it, in terms of building a tool for people to deploy their models easily, why is the differentiation between the structured data consumption type and the unstructured data consumption type, why is that relevant to you for the AI deployment layer?
Absolutely. That's a great question, actually. So I think your definition is right on. I do also think it can be blurry. So if you're going to be a machine learning platform that runs classification, prediction, inference, whatever you want to call it, what are the core tenets that you need to be able to do? One of them is I need to be able to retrieve data from somewhere. I need to be able to do something with it, the kind of classification process, and then I need to put the result somewhere, right? I mean, that's like core. Like otherwise, how does it get consumed from a application perspective? And so the core difference from a platform like ours is going to be like, how do you access these data sources? Because accessing a database and reading from a database and processing from a database and then putting it somewhere else is different from accessing and reading from a file storage. So that that's at the kind of like the base level of why you need to differentiate. So there's a data connector issue here where you have to build out, and then how you query those connectors and how you use them, and then how you move data through the system, right? It'd be really foolish to try to move a bunch of data off of a Hadoop cluster, right, to process them elsewhere and then bring it back to the Hadoop cluster, right? So you have to be careful because in some cases, these data sets might be giant. So from an inference and from a platform, you have to start thinking about data gravity. You have to think about where you're actually processing the data, how you're doing it, how you're connecting it, and what the actual best way to connect to those data sources is. So these are really, really relevant from a production platform, is understanding where, as I said, our goal as a company and our product is, and I tell this to our engineering team all the time, we should be able to lift data from anywhere, process it, and put it anywhere else. And so the actual differences between structured and unstructured data become really core to how the product interacts with the data sources at these companies. And to add to that, one thing that I think is particularly relevant is that we don't get to be prescriptive about how the data works or where the data is or where it's being stored. Because if you think about, if you're a deployment system, you're a production system, the data systems have already been created, right? In many cases, if you actually think about the general process of, there's data collection, data structuring, data modeling, and then production, and this is kind of follows almost any one of the analytical, any analytical process, everything from BI to, traditional, predictive analytics to machine learning. These deployments at the end, right? So this means that data collection was already solved to a certain degree. ETL processes already exist. There's a structuring component that already exists there. There's probably a training component, whether that be on the data scientist laptop or in a training system or whatever that is. And so we're coming at the end, which is exactly where we want to be, but all these other components are already there. So we actually have to adapt to make sure that we work with what already is there, because nobody's going to adopt our platform if we're trying to tell them, hey, you should change the way you do things for the first three parts of this process to just be able to use us. So a big part of what we do around our thinking is how do we get to be plug and play into the normal workflow of developers and be essentially as valuable as possible without having to influence any of the things around us.
I did a show a while ago with a company called Dremio. And Dremio, they're really working on trying to make data access within a large organization with a lot of disparate data sources a little bit easier. And in that recent show that I did with Tomer from Dremio, we talked a lot about how data is stored at a large company like Coca-Cola or JP Morgan with its 28,000 developers, or Procter & Gamble or State Farm, one of these older organizations that did not start out as a software company, but they have had to become a software company, and they have such a high volume of data. There's so much value trapped in that data. And so there's a lot of problems that are trying to be solved those companies are trying to solve. There's a lot of vendors that are trying to build the right solutions to give to those companies. And so I'm sure you're starting to look at this area because you're trying to solve one specific problem that these kinds of enterprises are going to encounter. So can you give me a picture for the data problems within one of these big enterprises and like how you're hoping to address those problems?
Yeah, so again, there's a ton of companies that are focused on the data problem, data management, data structuring, collection. And this is really something that we don't we can have an opinion and we obviously help drive an opinion around certain things, but we pretty much don't get involved. We really have made our platform plug and play with almost any data management provider out there, so that once this issue is solved for them, all we need to be is like, okay, what's your API to access these systems? And then we can pull in, we'll be able to pull from there or push to there with the kind of, like security and all that stuff that you do. So we try to be really, really not prescriptive on this because I think it's an entire industry to begin with. And so it would be impossible for a company to like focus on multiple of these things. When you're going to look at these companies, from that perspective, to your original point is that you have to just go under the assumption that there's going to be a level of like heterogeneous like data storage there, and that I'm sure that somebody would love to be like, we store everything in these three types of data stores would be great, but like that's never going to happen in a large organization. Like that only works maybe at a startup, and that's beyond that. It doesn't scale. And so then you start thinking about, okay, well, what's the data management process? What's the modernization? Like it gets exasperated even more. If you think about a modern organization today, any of the ones that you mentioned, now you're starting to say, hey, not only is it that like there's like dozens of different kinds of storage for different things, different use cases, different groups, but they're actually stored in different locations. Not only in different locations, sometimes in like completely different types of infrastructure. So you might have a team that is storing some stuff on Azure. You might have a team that's storing some stuff on AWS. You might have like really, really large data centers built out that are like, more traditional IBM, Oracle, like systems. And so an organization that is looking at saying, well, hey, we need to be able to access this data from anywhere and at any time and to build out the future of our machine learning systems is now thinking, well, I need to access all of this. How do I actually make this available under one plane? And that is actually something that like there's companies out there solving, right? So like there's companies that look at that problem as a whole and provide that. And companies like Tamer and Muta like are some of the ones that I'm familiar with, but like they're 100% focused on the security and access and kind of like trying to provide a homogeneous front to all these other systems that need to query data. But I think the core is that it's a huge problem, right? I think one of our large Fortune 100 customers, I had a conversation with their CIO, and they were saying they had 4,000 4,000 Postgres databases. 4,000, right? And again, like maybe that's an inefficiency. Maybe they only need 2,000. Like I don't know. I don't know enough about their business to be able to even like give an opinion around that. They're the experts, but that's the general. So these are the problems that they deal with. So there's a whole industry of data management that provides kind of like the front to access and access controls. And so when we come in as a production and deployment platform, our rule is we need to work with that. Like there's no way around it. Like we just need to work with those. And the good thing is that those companies have spent a ton of time and work on making their front end, right? Like API front end or their access front end pretty universal, right? So like they've done it through REST APIs, they've done it through like generic JDBC connectors. And so we can very easily plug into that and feed off of it. But like our whole point is that we start after that system has already been either developed or made present.
So if I understand you correctly, if I'm an engineer at a big insurance company and I've just been hired to improve the insurance rate risk calculator that is based on the data that's in these legacy data stores, I'm sitting down to build my machine learning model. I've already got the data connector problem probably solved for me. And otherwise, why would I have been hired to do my machine learning job? And so I'm sitting down to do my machine learning job. I connect to the data connectors. I start training a model, and the model gets good enough. I've trained it, and it works on my machine. And then I get to the point where I want to make it an API endpoint so that biginsurancecompany.com can access my machine learning model as an API endpoint. And so this is the point at which plenty of developers hit a friction, because there's all of these different things that go along with the deployment. Like, can you deploy in different languages? Are things getting cached appropriately? Are you running on a performant processor? Can you version your model? If you get a large influx of data and you want to build a new version of the model, but you don't want to maybe deploy it to every customer at once, maybe you want to do some A/B testing or something like that. Maybe you want to monitor and log your machine learning model deployment. The point here is that there are specific deployment issues for machine learning models that are probably not captured by other continuous integration systems, and that's kind of the problem that you are solving specifically.
Yes, so I think you described that really well. I do want to make one asterisk, which is I want to have to do a little bit of a shout out to some unsung heroes. So you said, hey, they get hired as these data scientists and all of this is solved problem for them. So ideally, yes, that's how it should be, right? But the fact is that a lot of these data science and machine learning heads and VPs of analytics are being brought in with none of this being solved, which essentially puts them in a role where they need to actually go solve the whole data management and data process. So you would hope, the ideal world would be, and this is what we advise companies, is that you can't really start with any real machine learning projects and data science projects until you've at least had this addressed to a certain degree. But there's plenty of, as I said, unsung heroes there who are being brought into these organizations who they actually have to go guerrilla warrior their way through every single one of those problems before they can even get started on what they got hired to do. So I do want to just point that out, because there's I know you have a lot of you probably have a lot of listeners in this space, and they're probably
they're doing data cleaning.
Yeah,
I've just told them that they're not doing data cleaning, and they're thinking, exactly. No, my job is data cleaning.
Yeah, exactly. So that they're sitting there being like, well, yeah, gosh, that would be great if that was actually how it worked. But so there's a lot of unsung heroes there who are fighting the battle all the way up. But if you're going to design the process, the expectation and the success, and you actually can correlate quite easily companies that have been successful in their data science and machine learning projects to having a very serious and dedicated data strategy for kind of the structuring and the modeling. And once that is available, truly bringing in these kind of really smart folks who can grab that data and iterate through it and build it, and then they want to productionize. And then absolutely, that's where we solve the issue of scale and uptime and the API part and moving it around, moving data around and scaling it, and then connecting multiple models together, right? So a big part that people don't think is that even in the world of model deployment, there's pre-processing functions. The classification functions might be 1, 2, 3. It's an ensemble. There might be a post-processing function. All that pipeline needs to be scaled together. It needs to be secured. It needs to be potentially audited if you're in a regulated industry. And so, as you said, the full CI/CD process plus the actual uptime is really where the problem becomes really apparent and where they need a solution. My kind of go-to the joke is usually saying look, anybody can run a web server. It's actually really, really easy to lift up a web server, but not everybody can run Reddit, right? So that's where the difference is, right? Like anybody could stand up a model with a simple API and run it on their laptop. But if you're actually going to depend on the system to run your business, if you're going to depend on the system to run at the scale and potentially like, either business critical or in some cases, if you think about government, like life, situations where there might be life and death involved, you better have security and audit and uptime and, the things that you need around that.
A thank you to our sponsor, Datadog, a cloud monitoring platform bringing full visibility to dynamic infrastructure and applications. Create beautiful dashboards, set powerful machine learning-based alerts, and collaborate with your team to resolve performance issues. You can start a free trial today and get a free t-shirt from Datadog by going to softwareengineeringdaily.com/Datadog. Datadog integrates seamlessly with more than 200 technologies, including Google Cloud Platform, AWS, Docker, PagerDuty, and Slack. With fast installation and setup, plus APIs and open source libraries for custom instrumentation, Datadog makes it easy for teams to monitor every layer of their stack in one place. But don't take our word for it. You can start a free trial today, and Datadog will send you a free t-shirt. Visit softwareengineeringdaily.com/Datadog to get started. Thank you to Datadog. So what's the conversation like with these enterprises? So as you've gone from the world of building a marketplace to selling to the enterprise, it's a very different world to exist in. So how have you sort of adapted your ability of selling, I guess, or what has that evolution looked like, from a business point of view?
Yeah, so I'd say probably like the two most important things are two P's: patience and partnership. So especially early on, really thinking through how you and this enterprise, like how do you bring value to them immediately? And then how do you work over a longer period of time to make sure that you continue adding value or increasing value? And if you can actually establish that partnership relationship with some of these these long enterprises, and on top of that, you have the patience, right? Because they go hand in hand, the results are really, really good. It's not a secret. Some of these enterprise deals can be like a kingmaking to a organization from a financial perspective, also from a reputation perspective. And so for us, it's really been, we started really early on, as soon as 2016 is when we started working with enterprises. We, kind of kept it for the most part on the down low, and, and it was a big part of exploration and partnership and, holding hand in hand and saying, okay, what do you need? What are the problems that you need? How does our platform solve them? How can we make ourselves more enterprise ready? And then the final part really is hiring people that have done this before. So, a little bit of I wouldn't say, we've added some personnel that is very experienced in terms of working with enterprises, and then, kind of holding to our first two things, which is, I said, the patience and the partnership part. Like, we treat our large enterprises not as customers, but we treat them as partners, where we understand that our product, being kind of at the forefront of this world, of this world of machine learning, like, needs to be constantly evolving, and there's no better people to help us evolve it than the ones with the actual problem that we're solving. So kind of like that mentality of partnership has gotten us really far.
So from an engineering point of view, when I look at this as a pure engineering problem, it sounds kind of like you're building a Heroku for machine learning models. You're really trying to give a solution where you take the problems out of the purview of the developer, and that's sort of what Heroku did in contrast to something like EC2. So how have you changed the platform itself? Because the platform before was, I think, more just about this marketplace side of things, but I assume you've had to build more tooling that is kind of internal or give, kind of a logged in experience as opposed to this like marketplace deployment experience. So how has the product tooling changed?
Interesting enough that it hasn't. And I'll explain exactly why. We had to run this thing. Like we, as Algorithmia, we had to run with over 70,000 developers, over 5,000 models, 24/7 on call, SLAs to large customers who were using our platform. Like we had to build all of this in what we, with a small team and being, a startup, it's always been automation. And so one of the things, if you think about it, we built a billing system for the marketplace. We built the audit system for security. We built, kind of like the security that we needed because we run random code from the internet. There's a bunch of things that we built as tools for ourselves, which ended up translating into exactly the features that enterprises wanted to be able to run this themselves. And at the end of the day, what they're looking for, if you think about, maybe there's no transaction system, but like they're running internal marketplaces, right? There's teams that are making available models inside these organizations, and there's other teams that want to consume them. So the actual interaction between the consumption and the creation is actually identical, even to the actual people who are actually involved. They're just all under one roof in an organization. So the tooling perspective actually we obviously advanced it, but the really interesting part is that the actual philosophy around how to do this has been, how are we going to enable a really small team inside these organizations to run a massive production system for machine learning across the organization? Happens to be that we've been running a massive production system for the world, and that we build tooling for ourselves. These things actually translate really well. There's obviously other things that things like certain features, but I would say that, if you think about single sign-on and kind of like auth controls and, being able to generate logs into an enterprise logging system. So there's kind of these extra enterprise features that we've actually had to go build as well. But the core from an engineering perspective hasn't changed at all, which is really fascinating and exciting, and actually why we've been able to ramp up so quickly into this kind of side of the business.
And the last time we talked, we had some conversation about the homegrown containerization and compute management platform that you've built. Have you done any re-platforming on the internal engineering side?
So at the core of it, our platform is Git, Docker, Kubernetes, right? Obviously, a bunch of complexity internally to that and a bunch of things that we've built. But that's kind of like the core components of our platform, and that hasn't changed. We've obviously advanced it. It's been fascinating to see Kubernetes advance at the speed that it's advancing. All great stuff for us. We have a general philosophy that if there's an open source project that we can, use and contribute to, and we don't need a homegrown solution, then that's the way to go. So we're constantly evaluating components of our platform and saying, hey, can we just use something that already exists out there? And so that's kind of how I would, that's kind of how we've approached it. There's been a lot of changes in terms of the inside those projects, right? So last time we talked, Kubernetes had almost none or very little GPU support, which is core to what we do. We run so many GPUs. And now Kubernetes has actually gotten really a lot better. It's not perfect. It's not exactly where we want it to be, but we've been able to actually start paring down certain pieces of our custom code to be able to take advantage of more native tooling inside Kubernetes that has also allowed us to accelerate so that we can invest a lot heavier in kind of other areas that are really not in the Kubernetes world.
Do you manage your own Kubernetes, or do you use one of these hosted managed Kubernetes providers?
We manage and build our own. So today we manage our own on a couple of different clouds. We also work cross-cloud, which is another thing that is probably really relevant. So we wouldn't be able to use one managed service to jump to the other managed service, although that sounds awesome. So if we can get there one day, that would be great. We kind of build out our own Kubernetes from scratch when we go and deploy and when we run ourselves.
Is that cross-cloud important to you from a failover perspective, or because some of your customers are on AWS, some of your customers are on Google, some are on Azure, and you want to be able to locate the models close to to their other infrastructure?
The latter is really the way to look at it. So data sources, data gravity is really important. So, so if you think about, data is expensive and heavy to move, but compute is super light and cheap. So especially with containerization and with things like Terraform and like scripting, like we can go build out very, very quickly compute resources in different platforms. Moving data tends to be the slower process. So, if you have a database in Azure, we're going to try to go build out our infrastructure in Azure to build it, to process that, but if your data is like somewhere in like AWS or in S3, we're going to want to build it out there. And then on top of that, on a per region basis, right? Because you don't want to pay the data transfer in between regions. So these are all things that, like, when you start thinking production, while in training, you're just like, well, the data's here, we're just going to build it here, and then we're going to tear the whole thing down. When you're actually doing it in production, like, the data might actually be in multiple different places, or the model is the one that actually needs to move from region to region based on where the data sources are and stuff like that. And so these are the types of problems that they only start being thought about once, hey, my model works on my laptop, what's next? And then they start realizing that there's this world of considerations that need to be taken, which is really where we specialize in.
So when we last talked, this is when I was still living in Seattle, in the Seattle area, and I thought Algorithmia was really cool because I think it's one of the most interesting startups in the Seattle area. And, it was fascinating, stopping by the office and talking to some people, talking to yourself. I'm totally unsurprised to see that the business has continued to succeed and you've found other verticals to get into. And it sounds like things are going really well, and it sounds like a fun and interesting job because there's a lot of opportunities for growth, of course, and other businesses to be built on top of it. What have been some of the challenges that you've encountered?
Well, I think any startup is going to have, growing pains, right? And so, going from 8 people to 16 to 27 to jumping beyond that, at every single jump, there is challenges from a company perspective on, like, how do you keep, on mission? Who are the, adding management layer, having people, kind of really rally around things and do that. So I think there's the general, like, kind of like growing pains of a startup. I mean, that said, it's still a super exciting place to work. I think that's probably the most exciting part of it all, which is we've been able to bring on a lot of really, really amazing teammates to kind of continue this mission and grow it. And it's accelerated everything. When you accelerate everything, you also hit potholes a little bit harder, right? So that's natural. And so, how hard can you hit the pothole without popping the tire is, something that, like, a startup is always testing, I feel like. But so that's kind of one of that. From a challenging perspective, I would say, growth is hard. So being able to define a new category, which is what we're doing, like, when we last talked, even though we were doing machine learning deployment, if you really think about it, like, nobody was talking about it. This is not a thing that existed. Not because most people haven't gotten to that side of the problem yet. Now it's actually a conversation. You hear a lot about it. You hear more companies popping up around it. You hear about, different cloud providers thinking about how they're going to solve this problem. And so, when we're essentially creating a new category where you're in a space where, this doesn't exist, but so now you have to actually, educate your customer on why you're needed, and then it's really obvious to them at that point, but then educate the rest of the organizations and the world on, like, hey, this is when you need us, this is when you don't, this is what we do, this is what we don't. That's really hard. That's a really hard problem to solve. So that's been another one of the places that we've spend a lot of cycles around, messaging and how we change things and stuff like that. And this, even this conversation with you, which has been fantastic. If you think about it, like, our product hasn't changed that much. I mean, it's gotten better, but the way that we have to talk about it, the problem solving, like, even you picked up on it, it's like, hey, this is kind of shifted. It's almost like a new vertical. So that is actually a challenge in itself, right? How to address that? How do you educate, yourself, your everybody in the team, the organizations you're interacting with, and then the world at large.
Diego Oppenheimer, thanks for coming back on Software Engineering Daily. It's been really great talking to you.
It's been my pleasure. Thank you so much for having me.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily, and thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow!